so we are getting ready for our trig quiz here. So we're going to start with some graphing. And as we've been talking about all the way through with these, we're going to deal with our help card here a bit. Now, this is when we get to the second part of our graphing. Once we have our x-axis situated, which we're going to be doing our radians and our parent points with. But as we get there, we've got to remember what the different parts do, what the different parts mean. So, first thing is, my amplitude. Different from my A value. Like, wait a minute, what? Okay, when we're graphing, I'll just use cosine as my example here. Okay, my A value is basically going to tell me what I'm multiplying my base numbers by. Okay, different from amplitude, which is a distance from my center line. My amplitude is always positive since it's a distance. So whether this A value is positive or negative, as far as my amplitude goes, doesn't matter. So it was positive this time anyway, so not a big deal. What that value does tell me, though, is what my highest or my maximum and what my lowest or my minimum values are going to be, since we're not dealing with vertical shifts yet. Now my period, also has its own little twist to things. Period is always going to be 2 pi over b. That's my equation. My b value is whatever number I see in front of my angle measure. If there isn't a number that I see there, we assume, in this case, it's going to be 1. But if I would have a number, that would go here. So 2 pi divided by 1 for this problem would mean my period is 2 pi. So what that 2 pi tells me is we're always going to graph 5 points. 0 is where I'm going to start. Whatever my period is where I'm going to end. Now, normally, when we've been doing these, we've talked about how, we're going to multiply each of my angle measures by 1 over b. But when you have 1 over 1, that really doesn't mean a whole lot. Because 1 over 1 is just 1. So if my b value is 1, or if I don't see 1 there, these are my points that I'm going to be using. So I'm going to be using pi over 2 and pi slash 3 pi over 2 and 2 pi. Nothing's changed. So that gets me set there, and then when I go to graph 1 period, pay attention to what the trig function is, because, again, this is a quiz on sine and cosine. I'm going to mix them up. So I notice here we're going to be doing cosine. My A value is 0.5. So I grab my calculator, use my brain, whatever I have to here. 1 times 0.5 is 0.5, so there's my first point. 0 times 0.5 is 0. Negative 1 times 0.5 is negative 0.5. 0 times 0.5 is 0. And 1 times 0.5 is 0.5. And again, this is what a typical cosine graph looks like, depending on if it's a positive or negative A value. Normally, it's going to kind of look like this curvy-looking U-shape, which ours does, so we feel pretty good that we did that right. And we did. And that's how we would graph 1 period. So, as we continue to do these, we might have a few things change, but that's not going to be a bad thing, because we're going to be ready for it. If I move this up a bit, now I look at this next one, and I go, okay, my amplitude is going to be 2, because again, it's a distance. But my A value is negative 2, because that's going to make a difference when I go to graph. But we'll get to that second, because we always do the stuff with our period first. When I get to period, I look for the number in front of my angle measure, in front of my x. This time it's 4. Okay, so if my b value is 4, my period is 2 pi over 4. I'm going to look to reduce the part in front of pi as much as I can. And I can put a 1 there too if I want to. So my period here, because 2/4 reduces, is pi over 2, or 1 pi over 2. So that would be my value on the end. The A value, or the amplitude, tells me how high and how low my graph is going to go. So basically now my biggest challenge in this problem is going to be, hey, how do I find these 3 values in the middle? Now we got lucky on the first one, and it was just, my B value was 1, but it's not this time. So I'm going to pull my little chart out here again. Okay, it says we're going to multiply by 1 over B. So here's how this is going to roll. Since my B value is 4, I'm going to multiply by 1/4. Flip my B. So for all 5 of my angle measures, I'm going to multiply them by 1/4, and that's going to get me my angle measure. I guess I'm going to use theta here. It doesn't matter what we really use. Ooh, that's a new symbol. I don't think that's a Greek symbol of anything. So when I multiply across, 0 times anything is 0. We knew that already. Pi times 1 is pi. 2 times 4 is 8. That would be my next line. Okay, pi times 1 is pi. 1 times 4 is 4. That's my next line. 3 pi times 1 is 3 pi. 2 times 4 is 8. That is my next one. And 2 pi times 1 is 2 pi. 1 times 4 is 4, but this time it reduces to pi over 2, which is what should happen. The last one in my chart and this one should always be the same. If they're not, we need to go back and look because some didn't quite go right. So once I have that set up, and we'll come back, we'll talk about halvesies in a minute, because some of you still are doing halvesies, which is all good. I notice this time we're doing sine. So I've got to make sure when I'm looking at my chart that I'm using the sine part. And again, I kind of know what my graph's going to look like. So it's the A value, okay, not my amplitude, my A value that I'm multiplying these by. So 0 times negative 2 is 0. 1 times negative 2 is negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 is positive 2. And 0 times negative 2 is 0. And basically what happens here is, because of the negative, this kind of flips over. So if I took that and went like this, you're like, oh yeah, no, it still doesn't quite. But instead of going up and then down, it goes down and then up because of that A value. But it's still a sine curve. It doesn't look like a big U. Now, if some of you have been doing halvesies, some of you might be like, okay, what's this halvesies thing he's talking about? Some of you have not liked playing this game with a chart, okay? And so what we do instead is, let me fold this up a little more, is back when we knew what this value and this value was, just from figuring out the period. One of the things we've done is said, okay, is there a way that I just keep finding the value in the middle, or the halfway point, so I can figure out these other values without having to play a chart? And there is. And so what we do in that case is we go, okay, I kind of forget about the pi for a minute, or I can still get it in there, but I can't do it on my calculator. Whoops, that's not going to help me. So here, if I forget about the pi and I consider it 1, it would be kind of like I'm looking at 1/2. So I go, okay, 0 plus 1/2. I need to divide it by 2 because I'm looking for the average. I'm trying to find the middle. And then I do math, enter, enter. And it says, okay, 1/4, which would be pi over 4. I just replaced the 1 with the pi back in. Then I look in between. I'm like, okay, 0 plus 1/4. Again, I don't use the pi here. I'm just using a 1 in that place. Divide it by 2. Math, enter, enter. 1/8. Or pi over 8. And then I got to do it one more time here. So, I mean, it does take a little more time, but if it makes sense to you, I say it's worth it. Divide it by 2. Math, enter, enter. 3 over 8 would be 3 pi over 8. And I want you to notice something. Let me bring that down a little. Same values. Okay? Halvesies work, the chart works. But we've got to get there. Okay? And we got to have pi's in here. We're speaking radian. We're speaking the Trig language of love. So we've got to speak in its language, or it ain't going to treat us well. I'm just saying. And so as we keep going here, we just kind of keep looking at these values. Okay? I don't see a number in front of cosine. We assume it's 1. So my A value is 1, and so is my amplitude. Then I go looking for my period. I look for my B value, which is 3. So my period is 2 pi over 3. 2 over 3 doesn't reduce. I can even try it in the calculator. You're going to find out the same thing. So I know my last angle measure is 2 pi over 3. My first one's going to be 0. My max is going to be 1. My min is going to be -1. And now, it's my job here again to find these in the middle. Either way works. If I go charting, let's see here. My B is 3. I'm going to multiply by 1 over 3. If it's a fraction, it can flip the other way too. Like if it was 1/2, I'd multiply by 2, or 2 over 1. And so I take a quick peek with my 1/3 here. I'm going to multiply across. 0 times 1/3 is 0. Kind of knew that. Pi times 1 is pi. 2 times 3 is 6. Pi over 6. Pi times 1 is pi. 1 times 3 is 3. Pi over 3. 3 times 1 is 3 pi. 2 times 3 is 6, but 3 over 6 reduces. We don't want to forget about that. 3 over 6 is 1/2, or pi over 2. Now comes the moment of truth. I know what the answer should be on the last one. Oh, I hope it is. 2 pi, 1 times 3 is 3. Those match. Or again, the halvesies would work. Keep adding up the values on the end, so I'd do 0 plus 2/3. Divide it by 2, I'd get 1/3, and keep going with it that way. My graphing, pay attention to what trig function it is. We're at cosine. So we pull that back up. Okay, it's just 1. So these are the values. 1, 0, because again, 1 times anything just gets me that value back. -1, 0, and 1. And I get my cosine graph. So as long as you've got any kind of background really with your card, there really isn't much reason you're going to get too overly stressed here or complicated. Unless over our, now 5 days of doing this, you haven't done any of them. In that case, that could be a little more complicated. One more graph, and then we'll put some of the pieces to use here. Oh, yeah, I'm glad we got this one here. Now we're going to get to see a little of everything. So we get to this last one. Look at my value in front. My A value is 2, so is my amplitude. My period. Okay. This time, I have a fractional B value. 2 pi over B. Now, if you put it in the calculator, 2 divided by a half in parentheses. If you do it manually, remember, dividing something by a half is the same as multiplying by its reciprocal. So 4 pi is my period. So if your b value is a fraction, it's going to make your period get bigger. And we'll take a look at both ways to do this one again as far as creating my angle measures. So this time, my b is a half. We multiply by the flip, by the inverse. So we're going to multiply by 2, or 2 over 1. You could just do 2. I just do the 1 because it makes it consistent. 0 times 2 is 0. Okay, kind of knew that. Pi times 2 is 2 pi. 2 times 1 is 2. But that reduces. 2 divided by 2 is 1. So that's just pi. Pi times 2 is 2 pi. 1 times 1 is 1. 2 pi. 3 pi times 2, 6 pi. 2 times 1 is 2, but 6 divided by 2 reduces to 3 pi. And now again, the moment of truth. 2 times 2 is 4 pi. 1 times 1 is 1. They match up. If you're a halvesies person, this would be like the absolutely positively best case ever for you scenario. Because if you stop and think about it, so I was looking, I'm like, okay, what's between 0 and 4? Well, 2 is, okay. Well, what's between 0 and 2? 1. What's between 2 and 4? 3. So again, it's your choice on how you do it, but there's at least 2 ways there you can pretty easily get to the right answer. I know because of my A value, I know what my max and my min values are going to be. Pull out my sine graph. My A value is 2, so I'm going to multiply each of these by 2. 0 times 2, 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. And we're good. Okay. So again, this mainly has come down to, are we practicing? Are we getting used to using the card or halvesies, whatever it is we use or not? If we are, I have a feeling you're going to be in pretty good shape. All right, now we're going to apply it. How many cycles, what's the b value for each sine function in the interval from 0 to 2 pi? Find the amplitude and period. Okay, so from 0 to 2 pi, how many sine graphs are there? Now again, sines go up and then back down. And so what I would do is I'd start at the beginning here and I'd be like, all right, max, min, back to where I started, okay? There's 1. Max, min, back to where I started. There's 2. Max, min, back to where I started. 3. Okay? 3 cycles. Or if you put b equals 3, that's fine. I'm good with either. Find the amplitude. Basically, find the maximum value. Okay, here's the top point. 1, 2. Okay, and even if it started opening down, my amplitude is still going to be positive. And then the period of each function. Okay, the period is 2 pi over b. But I just figured out what b is. That's the number of cycles. 2 pi over 3. I'll try to reduce the coefficient part. But if it doesn't reduce, and it doesn't this time, that's my period. Okay? B value and period. two different things. So I've got to be really cautious when I'm doing that to make sure I don't mix them up. And then the same thing on our last one here. Again, sine, max, min, back to the start. There's 1. Max, min, back to the start. There's 2. Max, min, back to the start. There's 3. I'm going to run out of colors. Max, min, back to the start is 4. I do have to pay attention to what function it is, though, because if it was cosine, now it'd be U-shapes I'm looking for. So, got to kind of think this through a little bit. Max, min, back to the start. Max, min, back to the start. Okay, so 6 cycles. So that's my B value. My amplitude, there's my high point. 1, 2, 3. And my period is 2 pi over b. But again, if the fractional part, not pi, don't put pi in, reduces, and this time it does, I need to do that reducing and get that set. And at this point, I would hope when we get up to numbers like 7 and 8, we've seen it back on the front. You've seen it on all the graphing equations. When you're looking to make an equation, whether it's sine or cosine, doesn't matter. Okay? Your amplitude will be your A value. If you're fortunate enough to be given the number of cycles, you're already being given the B value. Plug it in and be done. However, if I'm given the amplitude, but here I'm given the period, I can't just use 8 pi and call it good. What I'm going to have to do is I've got to figure out now what B is. So to do that, I use my period formula, 2 pi over b. I'm going to do some cross multiplying. And since I'm trying to figure out what B is, whatever's with B is what I'm going to divide by. Over here, don't let your eyes fool you. That doesn't say 8 divided by 2. It says 2 divided by 8. So even if you plug that in your calculator and do a math enter, okay, 1/4, not 4, and I get my B value to plug in. Okay, so I do have to do a little bit of algebra here to make this go the way I want it to. And so, as I keep going, you're like, well, wait a minute. Now it says cosine. What's different? Nothing. It's just the function that I write in the middle. Y equals amplitude. Now it's cosine. Number of cycles is still B. That didn't change. That's still straightforward. When I get to the second one, same thing as number 8 was. This time I'm given the period. I've got to know what B is. Now, to me, I can just look at that right now and tell you what B is going to be, because I see a lot of similarities. But if you don't see that, or if you're a creature of habit, there is nothing wrong with that. Cross multiply. Whatever's hanging out with B is what we divide by. Get my B value. Rocking and rolling. And as we head towards the end here, take a peek, we go, okay, error analysis. Error analysis means there is an error. Do not say everything's right, because it isn't. The student looked at the graph below and stated the amplitude was -2 and the period was 4 pi. What are the correct responses? What did the student incorrectly think? Okay, we got several things going on here. They say the amplitude was -2. Before I even look at the picture, what's the problem with that? Right, amplitude is always positive. So, first, amplitude is +2 because amplitude is always positive. You can kind of take care of both things that way because it says, what did the student incorrectly think? That's how you're kind of fixing it for them. So that's solid. Now here's the other part. They think the period was 4 pi. For the period to be 4 pi, -2 pi to +2 pi, that would have needed to have been one sine graph. Is that one sine graph? No. How many sine graphs is it? Let's see. So let's see. Down, up, and back down. There's one cycle. Down, up, and back down. There's 2 cycles. Up, down. There's 3 cycles. Up, down. There's 4 cycles here. Which means my b equals 4. So my period is 2 pi over b. I reduce that part to pi over 2. So let's see. Period is pi over 2. That's the correct one. What do you think? How could we describe the error they made or what we needed to do to fix it? This is something that I actually see people come up and ask me about. So, a couple of options here. Could be the student thought the whole graph equals 1 period. Because I've seen people see that. Oh, I just thought this whole thing was. Or you can say something like, they didn't calculate the b value correctly. Because maybe they went through and maybe they did, 4 divided by 2 instead of 2 divided by 4. That's still given 2 pi, but it could be something that made them think that's what it would look like. Either of those are good, though, but you can't just say they messed it up, okay? You've got to give me a reason on what you would think they possibly could be thinking. You've got to put yourself in the brain of somebody who doesn't get this stuff. And hopefully that's not you at this point. All right, the end. Turn each measure from radians to degrees and degrees to radians. All right, radians to degrees means we want pi to go away. So we multiply by 180 over pi. Because we talked about how pi and 180 are the same thing. They're equivalents in radians speak. If I'm going degrees to radians, though, I want pi to be there. So I multiply by pi over 180. One question I will not answer tomorrow. Which one do I use here? No, you have to figure that out. We've done it on homework. We've done it here now. You've got to know which, and here's how I know. If I see pi here already, I'm already in radians. I want to go to degrees. So if pi is already there, my first goal is to get rid of it. And I do that by putting pi on the bottom because then the pi's will cancel. Now I just multiply across, and reduce the fraction. And now I'm in degrees. Why? Because there's no pi left. If I'm in degrees already, it means we're going degrees to radians. So I multiply by pi over 180. Now this time nothing's going to cancel. So I multiply straight across. Again, looking to reduce this part. If you want, you can punch it in and math enter it. That's legit. 4 over 3. Don't forget the pi is there, because that was the whole idea here. And we're set. This is the quiz. I'm just changing a few numbers around. Okay? So again, knock out the homework check in case you need a retake, since this is our last regular summative, so you'll want to do that. If you have questions, let me know, and we'll get this out of the way tomorrow.